This is part 2 of adding and subtracting rational expressions. So remember that we need a common denominator in order to add or subtract rational expressions, just like with fractions. Now, yesterday we saw that we can have a monomial, so one term as a common denominator, but sometimes we may have a binomial instead for a common denominator. So let's take a look. So x plus 2y over 2x minus 4 plus 5 over 3x minus 6, and then subtract 2. Now, first thing I want to do is I want to simplify as much as I can. So I'm going to common factor each denominator. So the first denominator I can common factor out a 2, and I'm left with x minus 2. The next denominator I can factor out a 3, and again I'm left with x minus 2. And then I have minus 2 here. So I can see already that the binomial x minus 2, I have that in common with these first two terms. So I think that I want my common denominator to have x minus 2. It has to have that binomial. Now, it must also have the same coefficient. The common denominator must have the same coefficient. So right now, these are not common denominators because this has a coefficient of 2 and this has a coefficient of 3. So just like we did yesterday, between 2 and 3, a common multiple would be 6. So if I want to change this denominator to 6 times x minus 2, I have to think, okay, what would I have to multiply the numerator by? So what I've done here is I've multiplied the denominator by 3, so the numerator must also be multiplied by 3. For the next expression, I had 3 times x minus 2, so if I want to change that to 6 times x minus 2, that denominator would have to be multiplied by 2, so that means the numerator would also have to be multiplied by 2. Now just remember, if I'm going to show that I'm multiplying the denominator by 2, I would have to show the same thing in the numerator as well, just for communication, so I'll correct that. Now remember that minus 2, if I were to write that as a fraction, that would be minus 2 over 1. So if I want that to have the same common denominator of 6 times x minus 2, then both the denominator and the numerator would have to be multiplied by 6 times x minus 2. Alright, now I can start bringing things together. So what I can do first is I can have one long expression. Now try to make this as straight as possible. It's hard for me to write it with the Mobi. So 6 times x minus 2 is my common denominator, and I can start expanding everything out. So 3x plus 6y. Now right here I'm adding 2 times 5, so I'll be adding 10. Now over here I am subtracting this expression right here, so the sign's going to change. So that'll be minus 2 times 6, which is minus 12. Let me just put that there instead. Minus 12 times x minus 2. And then I can expand that even further and simplify again. So 3x plus 6y plus 10 minus 12x plus 24, because I'm multiplying by negative 12, and then all over the denominator of 6 times x minus 2. So now combining any like terms, 3x minus 12x is minus 9x, plus 6y, no like terms for that, and then 10 plus 24 is plus 34 over 6 times x minus 2. Now at this point I don't want to be satisfied with my final answer. I want to see if there's something that I can common factor out of the numerator so that I can maybe divide out something in the denominator. But there's no common factor for 9, 6, and 34. So this is my final answer right here. And I only have one restriction, that x cannot be equal to 2. Now sometimes it may not be so clear what the common denominator is. So the easiest way to find a common denominator is just to multiply the two denominators together. So for example, if I have 2 over 7 times 1 over 9. I can start to think what are some common denominators or common multiples of 7 and 9. Or what I can simply do is multiply 7 times 9 is 63, and then that would be a common denominator. So that would work. Now, we can use this idea if we have binomials in our denominators. So in this case, I have x minus 4 and x plus 1. Those are different binomials. So to find my common denominator, what I will do is multiply them together. So the first expression, if I wanted to have a denominator of x minus 4 times x plus 1, okay, so that would be my common denominator between these two. This means that the denominator was multiplied by x plus 1, so that means the numerator must also be multiplied by x plus 1. Now, a good way to look at this is if we were to simplify this, x plus 1 and x plus 1 would divide out, and we'd be left with 2x over x minus 4. That's one way that you can tell that you've done your common denominator properly. Now, I'm going to subtract the next one. Now, this binomial was x plus 1. So I'm going to multiply that by the other binomial of x minus 4, and that means that this expression right here, because I multiplied the denominator by x minus 4, the numerator as well must be multiplied by x minus 4. Now I can expand everything and simplify, so I'm going to write this as one expression now with the denominator of x minus 4 times x plus 1. So I'll have 2x squared plus 2x. Now this is a minus 6x, so when I expand it I'll get minus 6x squared and then plus 24x, because that's minus 6x times negative 4. Alright, and collecting like terms now. So I have my denominator of x minus 4 times x plus 1. 2x squared minus 6x squared minus 4x squared. 2x plus 24x is plus 26x. So at this point, I want to look at this expression and see if I can simplify it at all. Now, I would be able to common factor the numerator. Negative 4 and 26 can both be divided by 2. I can also factor out an x as well. However, that's not going to help me at all. I'm not going to be able to divide out any of these binomials in the denominator. So that will be it for my answer. Now I also do have the restrictions. Taking a look at the final answer as well as all my steps, x cannot be equal to 4, and it can also not be equal to negative 1.